Hey guys, welcome back. Let and const rather than using var. So, if you are a JavaScript developer from ages, you must be having this var keyword running in your veins. Just as we discussed, that we have already written a lot of code that uses JavaScript's old constructs, you would agree that it is nearly impossible to remove that code from all the applications in this world. And this var keyword is the hero for that code. You will find no code without var because that was the provided way to create a variable, right? But now things have changed. Var should no longer be a part of your application's code because there were some serious issues with this var keyword. Let's discuss those issues. The one major drawback with this var was that it was not block scoped. You guys might already be knowing what is a scope and how scoping work in JavaScript. Scope is a context in which variables and functions are accessible. In JavaScript, there's a global scope for outermost variables and functions that are accessible globally, that is, they can be accessed everywhere. There is a function scope for the variables and functions present inside a function. So they can only be accessed within that scope. And there is a block scope for the variables and functions present inside a block. So they should also be accessible within that block only. But the var keyword do not follow this third rule. So if I have a function, let's call it foobar, and in this function, if I create a variable, let's call it foovar, I will be able to access this variable inside this function, right? So I can do whatever I want to do with this variable. So let's just log this foovar out, and now let's call this function foobar. Now if I run this code, node var keyword, I see that yes, I am able to access this foovar because it is accessible inside the function scope for that particular function. Now if I try to print this foovar or try to access this foovar outside of the function, I get error. It says foovar is not defined, which is quite normal, which is the expected behavior because I don't mean to access this foovar outside of that function because I've created that var inside of that function, right? But in case of block scope or in case of a block, this is not the case. This time let's have a block and I declare a variable within this block using var. Foo is bar and it is fine until I'm able to console log this right here. So I'm gonna log it here inside this block. And now I see what I get. So I get bar. So I'm able to access this foo inside this block scope. But if I do the same outside of this so-called block, and if I print the same variable right here, even if we're not having this foo outside of this block, still I'm able to access this bar. Why the hell it behaves like this? I have something that should remain restricted to a block only. Why can't it just be there? If I really wanted to have it outside of that block, I would have created it that way. But I don't want this food to be accessible outside of this block. Still, I'm able to access it. That's the problem with this var. The only possible way to make it work, to have this var exclusive to this block only, is to use an iffy here. So if I enclose this within an iffy, just like this, then I'll be restricting the scope of everything inside this iffy to this scope of that iffy. But this is really an ugly way to do the stuff. So let's drop that. But The point is, what I have shown you is a very basic representation of the issue. It might get on nerves when we write statements in real applications. For example, if I write a for loop, let's say this loop starts from 0, goes till less than 5, and each time we are incrementing the I. So here inside this loop, let's log this I each time. And now let's run this. As expected, it prints out the values of I in each iteration. But if I print this I outside of the loop, let's say right here, if I do console.log, and if I rerun and see, uh-oh, I haven't saved the program yet. Okay. Now let me run this again. So see, it is able to access this I even outside of the for loop. We can see the last value uh, when the for loop got terminated was 5. So it was able to access the value of I. So it still is able to access I outside of this loop, which means I is not something that can only be modified within this loop. If I want to assign some value, I can do it even outside of the loop because var does not have block scope. Also, if we go more close to the problems that this not having block scope for var thing is having, if I write the function set timeout inside this for loop function, and let's print the value of I on the screen, I is this, and let's give it a duration of 1 second before logging the I on the screen for each iteration. And if I run my application having such code, what we all see is this. So why does this happen? We were not expecting this. Why are we not having all different I's? The reason is that this I is not a variable which can only be accessed within the block. Rather, it has got created for the outer scope, which here is the global scope, right? If you guys know a term called closure, which is the ability of a function to remember a reference to a variable used within the function itself, but it has not actually been passed into that function. For example, if I have a variable fooVar, let's say it has some value, hey there, and then a function that uses that variable, log fooVar. Here I'm just going to print this fooVar inside of this function, and now I'm just gonna call this log fooVar. So let's run this. So see, it prints hey there. So even if we're not passing this fooVar to this function, anywhere this log fooVar function is called, it will always be able to remember what value fooVar holds. This is how closure work. Or if you want me to deliver more visibility over closure, let me do some modifications. Let's say if I wrap this code within a function, let's call it outer function. And let's say everything is written inside this outer function. And then if I run this inner log fooVar function somewhere else in an entirely different place, first let me return this function from this outer function so that I can access it outside. And now here I write another function and inside of it I get this log foo function from this outer function. So I'll be calling outer function. This will return me the log foo function, and then I'll run that again, run that as well. So let me call this other function so that it can invoke the outer function and the log foo present inside the out function. Now let me run this. So see, it still is able to print hey there. So even if I'm calling the function in an entirely different place, I'm calling this log foo entirely in a different place, it still is able to maintain a reference to this foo variable, even if it is not passed anywhere. So this is how closure works. So now coming back to this for loop, we know that var is not block scoped, right? So if we create this var for a block, it is actually created for the outer scope. So it is getting changed globally as it's created in the global scope. Each different iteration is having the same var I with just an incremented value each time. And in this set timeout, it is able to access that var I as a closure, because if you see, we're not passing any value in this set timeout. Whatever it is getting is from the outer environment, which for our case, for this example, is the global scope, right? And if I talk about this function set timeout, functions like set timeout are implemented natively, or at least outside of the single-threaded JavaScript. So their callbacks are triggered by the environment in which we are running that JavaScript application. It's the environment that puts these callbacks first into a queue, and then they are picked up from that queue by this single-threaded JavaScript engine. So by the time these set timeout calls starts to run, I has already become 5. That's the reason for each iteration, for each block we get 5, because I is available globally, right? So this is issue when we use var. Let's see how let and const overcome this issue in next lecture.